Welcome to The Explainer. I'm your host, and today we're unpacking a massive, honestly pretty shocking surprise from the recent Suez CSE Carnival. We're looking at a project called the QStorm Investigator. Now, on paper, it's a really slick tool for handling digital finance complaints. But behind the scenes, the team made a wild 11th-hour architectural pivot that goes against literally almost every tech trend happening today. Let's see why they did it. So picture this. You are in a highly competitive, high-stakes hackathon environment. You've built this incredibly impressive prototype. You're using a cutting-edge Gemini AI model to process complex customer support tickets. It's smart, it's flashy, it parses natural language like absolute magic. But then, right before the final submission, you scrap the AI entirely. You just toss it out. Why? Why on earth would a team actively choose to abandon a powerful AI prototype in favor of a basic deterministic rule engine? Well, that is the core mystery of the QStorm Investigator, and the answer is deeply rooted in the harsh, uncompromising realities of production-level engineering and automated judging. To understand that massive pivot, we first need to look at what this tool actually does. QStorm Investigator is billed as a support ops evidence co-pilot for digital finance complaints. But, what does that actually mean in practice? Well, it means this system doesn't just blindly read a piece of text and guess what category it belongs to. Instead, it actively investigates the customer's complaint by cross-referencing their claims directly against the hard evidence of their recent transaction history. It's literally acting like an automated digital detective, prioritizing concrete data over assumed intent. And this detective work is built on a surprisingly simple architecture. QStorm is designed as a lightweight, stateless Django REST API. And by stateless, I mean it doesn't store ongoing, messy session data in the background. It just takes a secure input, does the heavy lifting, and fires back an answer. It exposes a very clean, tightly controlled two-endpoint surface for the hackathon judges. You've got a simple GET request on the health endpoint for checking the system's readiness, and a POST request on the analyze ticket endpoint where the actual ticket investigation happens. Keeping the surface area this small, stateless, and focused means the API is incredibly fast and, more importantly, totally predictable to test. Okay, let's dive into this flow. Once that POST request hits the API, it triggers a lightning-fast, 5-step backend journey. First, the text complaint and the structured transaction history enter the system. Second, the system classifies the exact case type. Third, and honestly, this is where the magic happens, it scores the transaction evidence. Then, step 4, it locks in a definitive reasoning verdict based entirely on that evidence. And finally, step 5, it returns a highly structured, remarkably safe JSON response containing absolutely everything an agent needs. We're talking verdicts, severities, department routing, reason codes, and even a human review flag. Right, so now we arrive at the big pivot. In their earlier prototyping stages, the team was actually running that entire 5-step flow through a hosted Gemini AI integration. They were relying entirely on the large language model to interpret the text and output that complex structured JSON. But if you've ever built something for an automated judge, you know that flashy features often lose to raw stability, like every single time. Realizing this, the team made the bold, calculated decision to just rip out the Gemini model entirely and replace it with a custom-built deterministic rule-based engine. Because relying on a hosted LLM during a live automated judging scenario, that introduces some truly terrifying vulnerabilities. Like, what if the API key fails or hits a sudden rate limit? Or what if the AI hallucinates unexpected data values that instantly shatter your required JSON schema, causing the whole system to just crash? Or consider the absolute nightmare scenario in a fintech setting. What if the AI generates fundamentally unsafe wording, like hallucinating an unapproved refund? The unpredictability of an LLM was simply way too massive a risk when perfect scoring was on the line.
So you might be wondering, without an AI to dynamically understand context, how does the new system actually work? Well, it relies on an incredibly robust, deeply hard-coded keyword pattern matching system. And because this was built specifically for the US-USCC SE Carnival, it handles regional linguistic complexities seamlessly. The engine reliably detects complaint categories by scanning for predefined keyword patterns across English, Bangla, and even Banglish. It doesn't rely on unpredictable model interpretations. It relies on strict rules that trigger exactly the same way every single time.
During that investigation phase, the engine is remarkably rigid. And what's really interesting about this is how strictly the engine compares the financial logs against the customer's complaint, using 4 exact criteria: the mentioned monetary amount, matching the specific counterparty involved, determining the expected transaction type, and checking the current status of that transaction. So, if a customer complains about a failed 500 taka transfer, the engine scans the history explicitly looking for a transaction matching that exact data profile. It is a pure, logical, mathematical evidence match. And because that evidence scoring is so strictly and deterministically defined, the final outputs can be perfectly controlled. Based entirely on the matching logic we just discussed, the engine locks in one of three definitive verdicts. The transaction evidence is either consistent with the user's complaint, it's inconsistent with the complaint, or there is simply insufficient data to make a call. Think of this engine like a really stubborn bouncer at an exclusive club. There's no middle ground, and there's absolutely no room for the system to just invent a new category to let an edge case through. Which brings us to a massive priority for the developers: absolute safety. In real-world digital finance operations, a customer support bot cannot, under any circumstances, solicit user credentials. That means no asking for a PIN, an OTP, a password, a full card number, or a CVV, period. Similarly, it can never autonomously confirm a refund, a reversal, an account unblock, or a recovery. By using a rule-based engine, the team was able to hard-code these never policies to be physically unbreakable by the system. So, the crucial point is this. What happens when this strict engine hits a gray area? Well, it doesn't guess. It immediately triggers a strict escalation protocol. Any case deemed risky, high value, disputed, suspicious, inconsistent, or honestly even just slightly ambiguous is instantly flagged with a human review indicator and routed directly to a real live agent. The system is fundamentally designed to know its own limits, because in fintech support, safety and accuracy must always override the desire for full automation. The deployment environment they set up is rock solid and standard. It's a Python Django REST framework application running efficiently on an AWS EC2 instance behind a Junicorn server. They've properly disabled debug mode to prevent any judging data leaks. But the real genius here, there's no external AI key required. By removing that dependency entirely, they made the deployment incredibly fast, fully self-contained, and perfectly reproducible. It literally eliminates one of the biggest points of failure for the judges. And this brilliantly illustrates the core philosophy of their final submitted build. I absolutely love this summary quote from the project walkthrough. It says it's, quote, a fast, safe, schema-correct support copilot focused on evidence reasoning rather than fragile model output. In an era where literally every single tech team is rushing to blindly bolt generative AI onto their product, this team won by recognizing that sometimes the smartest, most effective engineering choice is a predictable, highly constrained rule set. That leaves us with a fascinating, almost paradoxical question to ponder. As large language models become increasingly powerful and ubiquitous, the temptation to deploy them everywhere is only going to grow. But looking at the QStorm investigator's strategic pivot, will strict, deterministic, rule-based engines actually outlive AI in these ultra-critical, high-stakes fintech operations where safety, exact phrasing, and perfect predictability are just non-negotiable? It's the ultimate tension between boundless capability and unyielding safety. Thank you for joining me on this explainer. Until next time, keep exploring the hidden structures behind the systems we rely on every single day.